All right, you guys, I hope you did well on your quiz. The next lesson that we're going to go into is lesson 10-4, which is talking about inscribed angles in a circle, inscribed angles. So the angles we've talked about so far on circles are central angles. And if you guys don't remember, I'll just review this with you for just a second. A central angle has to be something that contains the center of the circle. And then this arc, like if this was A, B, and C, the arc of A to B is exactly the same. It's exactly the same as the central angle. Well, we're going to be discussing something that deals with an inscribed angle. So let me draw that for you real quick. An inscribed angle is an angle that is on the circle, not in the circle. It's actually on the circle. It's created by two chords that make an angle, and the vertex has to be on the edge of the circle. So A, B, and now C. This angle would be the inscribed angle because it's still inside the circle, not inside the center. Okay, so keep that in mind as we do this. Okay, we're just going to review this real quick before we go into the lesson. How would I find X, find the measure of each angle? How would I find the measure of each angle on this picture? Well, I would need to find X first. First thing I need to understand is that it's a four-sided shape, so it's a quadrilateral. All quadrilaterals add up to 360 degrees. So we would say 2x plus 12 plus 2x minus 20 plus 48 plus 80 equals 360. And that's how I would set up that problem to find my x. Well, then I would get 4x plus, and I'll just do all these together. I'm going to add up 12 minus 20 plus 48 plus 80. And I get 120. 360, subtract 360, subtract the 120 from 360. I get 240, so 4x equals 240, and then we'll divide by 4. So x is 60. So that's not the answer. They wanted each angle. So now I'll take the 60 and times it back in here. So I'll go 2 times 60 plus the 12. It's going to be 120 plus 12. It's going to be 132 for this one. And then this one will be 60 minus 20, which is 40. Because, well, 120, sorry. 120, so it'll be 100. It's going to be 2 times 60 minus the 20, that's 120 minus 20, that's 100. So my two angles, angle D and angle C on that one would add up to 132 and 100. If I add up all of those angles together, they will add up to 360, and you can check that. Okay, we're going to hurry and do this one because it's a different shape. This one is a triangle. Now we all know that we've learned that all triangles' angles have to add up to 180 because it's a three-sided shape. So A plus 3A minus 2 plus 2A minus 16 will equal 180, and we'll do the same thing. So we'll add up all of our A's. 1, 3, that's 4, 5, 6. So 6A, and then negative 2 minus 16 more would be negative 18 equals 180. We'll subtract, we'll add the 18 this time. This is subtract. And 6A equals, it's going to be 198. And we'll divide by 6. 198 divided 6 is 33. So A equals 33. That's going to help us go find each angle. So this angle is 33. This angle will be 3 times 33 minus 2, 97. And then 2 times 33 minus 16. And that'll be a 50. And so angle X is 97, angle Y is 50, and angle Z is 33. And if you guys will remember, the way we write those is the measure of angle Z would equal 33. And you could do that for each one of them, but I'm just kind of going quick so that we can get through this. Okay, this shape over here is isosceles trapezoid. It's a four-sided shape, so we do know that all four angles will add up to 360, but they only gave us two of them. But they did give us consecutive ones. And this is an isosceles, because two sides are the same, isosceles trapezoid. An isosceles trapezoid, what's unique about them is the consecutive angles, the ones that are right next to each other, add up to 180. Because the other two would have to add up to 180, and 180 plus 180 would be 360. So for this one, we would just say 4x minus 1 plus 2x plus 7 equals 180. So it's recognizing the shape. I mean, this one was just a regular quadrilateral. This one was a regular triangle. This one was a special four-sided shape, isosceles trapezoid. Then we have 6x plus 6 equals 180 when I do my combining of those two and the combining of these two. And then I'll subtract 6 this time. 6x equals 174. 174 divided by 6 is 29. And now I'll plug it back in to find each angle. So 4 times 29 minus 1 will be 115. So this angle right here is 115 degrees. And then this one would be the rest of 180, but I'll just type in 2 times 29 and then plus 7. 65. And that's how you would find each one of those angles, okay? So on each problem, you had to find the variable first and then plug it back in to find the actual things. Okay, those are just some reminders of some previous lessons. All right, now we're going to jump into our lesson for 10-4, inscribed angles and polygons. So inscribed angles, okay, and this is an inscribed angle. The red right here is the inscribed angle, and it's an inscribed angle because the vertex is on the circle. The definition they have is great, but my definition for an inscribed angle, the angle better be on the edge of the circle, not on the center, okay? Once the angle is on the edge of the center, or on the edge of the circle, then what we have is we have an arc created by the angle. And that arc would be the intercepted arc for that angle. And so the suspended angle will always be held by the arc, or it will be held by the chord. And so that's the angle that is suspended for it. That's what they call it. Okay, so that's what it looks like. We'll jump into a rule now. What I like about this rule is it's really pretty awesome. So this arc right here, this arc will always be twice as big as this angle, okay? So let me give you a heads up on it. Let's just review it real quick. If I knew that this angle was 30, then this arc right here would be 60. It's that simple. It doubles, okay? Now do not let that confuse you with this. If the angle is from the center, remember it's the exact same. So if this was 70, this would be 70. Everybody with me? But remember, now watch, what if I drew in this? See the green? It creates an inscribed angle. Well, then this arc is going to make this 35. It's going to be half as big. Does that make sense? I hope so. It's a really slick little rule, but it helps us find some of these inscribed angles, and it helps us find some of the arcs that are created by these inscribed angles. Okay? And they said we are going to talk about some polygons inside a shape. So polygons, I want to have you understand. So here's an inscribed polygon. So you guys take a look at this. That's a triangle inside a circle. That's inscribed because it's inside of it. So take a look. We've got an angle here. Okay? We've got the arc for it over here. So this angle right here and this arc will be related to each other. Okay? Everybody with me? Watch this one. This angle right here will be related to this arc over here. See how that works? And then this one over here, here's the last one. This angle right here will be related to this arc over here. Now, what's unique is we know that all three of those arcs have to add up to 360. Well, what's half of that? 180. That's what's pretty cool about this. It works. I mean, it's fail-proof. You guys remember when I talked to you about if you stepped off of a building, what's going to happen? Gravity's going to take over. It's a law. It has to happen. Well, this is a law. This law about inscribed angles, it's true all the time. And so if I have the blue angle, all I would have to do is double it and I would have the arc created. Okay? So we'll jump ahead. All right, well, let's see how this works. It says find the indicated angle, indicated measures. Well, we're going to find the measure of angle T. Well, angle T is right here. And sometimes it really helps to draw this in. So watch. I'm going to draw this in red. Here's the angle I want. Here's the arc that it created. Okay? So 48 is the arc. So half of that will be this angle right here, which is 24. So 48 divided by 2, 24. On this problem, they want us to find the measure of arc, QR. So watch, here's the angle that created it. Here's the arc that it made. It's in blue. So the angle is 50, so this will double. So it would be 100. So it would be 50 times 2, 100. And so it's either cutting things in half or doubling them a lot with inscribed angles and their arcs, okay? All right, let's move ahead. Find the measure of arc R to S and the measure of angle STR, so T is my vertex. Do you notice anything about angle? Do we notice anything about, so let's go find those first and then we'll talk about this. All right, so let's see what we've got. We've got an angle right here of 31. Well, the arc that makes it is right here, S to T, and so we'll double that. So 31 times 2 is going to be 62. So 62 is right there, okay? And that is the arc for R to S. So the measure of arc, R to S, equals 62. That part's done. Now let's go find the measure of angle, so let's go look at it. Angle STR. S-T to R, so I'm going to do it in blue. Okay, we'll hold up. And that is the arc that is creating it. It's the same as the red. It's the exact same as the red, so what does that tell us? That tells us that those angles must be congruent. They are. So the measure of angle STR has to be 31. So basically it's this. If two inscribed angles make the same arc, they have to be congruent. So what do we notice about STR? STR and RUS, they are congruent. They have to be. And that's what this next little slide is going to tell us. Okay, so basically it's this. If I have one angle and I have another angle and they both are creating the exact same arc. So this angle in red creates the red, and the blue angle creates the arc that is the blue. Notice the blue and the red are on the green and they're both the exact same, then that means they have to be congruent. And that's a law, it's a rule. All right, well, let's go on and let's see what we can figure out. It says, given the measure of angle E. Given the measure of angle E, it's right here. Find the measure of angle F. Well, let's take a look at it. I really like drawing these in. Okay, this is already in blue, so this arc will be blue. So this would be 175 times 2, which would be 150. Sorry, not 175, just 75 times 2 would be 150. Okay, because it doubles. Then they want us to find the measure of angle F. Well, angle F is down here. Take a look. Its arc is up here. It's creating the exact same arc. So that must be 150 as well. So this must be 75. So it'd be 150 divided by 2, 75. They are congruent. And it does help to draw the stuff in so you can see it. Okay? Anyway. All right, let's go on. All right. Well, we have an inscribed, it says find the measure of each red arc or red angle. Well, they want us to find the red arc, the red angle. If that's 90, well then this angle has to be 45, you guys, half of it. If this angle is 38, we have to double it. It's gonna be 76, I believe. And it is. And now we have an angle 72 that's inscribed and it's creating this arc. I'll do it in blue so that you can see it because it's a blue angle as far as the letters. 72 times 2, 144. Notice the red angle is the one we want to find and it is creating the exact same blue arc. So this has to be 72 as well. And that's it. We found them all. All right. Inscribed right theorem. The inscribed right triangle theorem is this. Basically, if I have a diameter and it creates an angle in it with a triangle, then this is 180, everybody. Everybody agree? Any diameter is 180. Well, take a look at the arc. It's an inscribed angle over here, so this has to be 90. Okay? And that's what they're trying to describe to you and help you understand. Okay? Any diameter will create an arc of 180, so its inscribed angle has to be 90. This one's pretty unique. It's pretty awesome. Any four-sided shape has to add up to a 360, correct? Well, if it's 360, then our opposite angles have to be 180 apiece. So really, if I have this one, I can find this one. Okay? If I have this one, I can find that one. All they do, the angle D and angle F have to add up to 180. Angle E and angle G have to add up to 180. That's because, look at the arcs. They are creating each other so that it's half of the circle. Now, it's not exactly half of the circle because this isn't going through the center, but if I go all the way around, it's 360. So half of 360 is always going to be 180. And so two angles are half of the four total. And so opposite angles have to be 180 when you have an inscribed quadrilateral. Okay? That's the quadrilateral rule. Okay, so let's see what we can figure out. Well, I see a diameter. That's one thing you have to recognize. And it's in a triangle, so we know this is 180. But we know that this is not equal to it. It's half of it. So this has to be a then 90. And so we'll say 2x equals 90. Divide by 2. And x equals 45. Okay, find the value of each variable we just did. All right, well, it's a four-sided shape inside of a circle, so it's inscribed. So we're going to look at opposite angles. So I'm going to say y plus 120 equals 180, because that's half of it, and there's the opposites. And then I'm going to say z plus 80 equals 180. And we'll solve this one. Minus 120, y equals 60. And z here, minus 80, z equals 100. And that's it. That's how you would find those variables for those problems. All right, this one's a little bit different. They're just asking us, okay, your camera view is 90-degree field. You have a 90-degree field, so we know that this would be across. If we had an entire circle on it, that would be the diameter, okay? You stand at a location in front of the statue that is, the statue is all that appears in front of the camera vision. you want to change your location. So you want to move somewhere around on this thing so that you still only see the front of it, okay? Well, to do this, we would need to make sure that you understand where you could actually stand. Well, we would need to make sure we had a radius, you guys. Well, our radius, and yeah, I know most of you don't have a compass at home or whatnot, you might. Our radius would be from here straight up to the edge of it. Does that make sense? Okay? So that's our radius. That's the distance from our shape as far as being able to get a circle going on this thing. Actually, I need to change that, sorry. Our radius is this distance here, and we've got to be able to understand that this circle, we would need to have an inscribed circle so that all three of the points would be touching the edge of the circle. Well, that arcing motion would be coming like this. And for sake of time, you know, I'm just going to show you exactly what I'm talking about as far as where these points could be. Our points would have to be anywhere where we can create a 90-degree angle, you guys. I'll do the next one in green. And our other one would be here so that anywhere on there was a 90-degree angle. So we've got only two other locations you could actually put it on to take the picture and only see the front of the statue. So basically, if we created a 90-degree angle here, anywhere I would want to take the picture would have to create an exact 90-degree angle on each spot, because we only want to see the front of it, and that would be the inscribed amount, which would be an arc of 180, if that makes sense. Okay? It's kind of a different question. It's really not that. I don't know how many you would even see on yours like that, your assignment. Most of your problems are going to be like this. Okay? All right, so let's go figure out what the missing variables are for each one of these. All right, well, we know that this is a diameter, so this is 180 from here to here. This is inscribed, so that's got to be 90. So x equals 90, and if x is 90, you guys, and this right here, this one would be 80, this arc from here to here. So if I take that and I subtract those from 360, I would get 100. Total 360, so this has to be 50. Now, that's not the only way I could have done that. Once I found this was 90, all I would have to do is take 90, 40, and subtract it from 180, and I'd get the 50 anyway. So there's a couple of different ways you can do it. I like to actually show the 360 and then the 180 for any triangle. Okay? All right, so let's go back over to this one. Number 5. All right, we have a diameter again. It's important because then this would be 180 again. And that only happens if it goes through the center. So then this is 90. So y equals 90. And if y is 90, then the rest of this would have to be our 35, I believe. So we'll go 90 minus 55. We get 35, and so this one here has to be 35. And so we'll go 2x equals 35 divided by 2. X is going to be 17 and a half. So 17.5 for that. Now we'll do this one. Okay, now we're not doing a triangle. Those are both triangles that actually had diameters. Okay, these shapes are going to be inscribed polygons, which are four-sided shapes, a quadrilateral. So opposite angles are going to be 180. So we'll start out with x plus 82. Let me write that a little better for you. Plus 82, these two equal 180. So I'll go minus the 82, minus the 82, cancel, cancel, x equals 180 minus 82. is going to be 98. And then y plus 68 equals 180. Because those two have to add up to 180. And 180 minus 68 is 112. So minus 68, minus 68. Okay, same thing's going to happen over here. We just have a little bit bigger items. So watch. There's no actual angles like these. They're all just variables. That's okay. It doesn't matter. Just set up your equation. We know opposite angles add up to 180. So 8x plus 10x equals 180. It's going to be 18x equals 180. We'll divide by 18. We'll get 10. So 10 is our x value on that one. And then we'll set up the other one. It'll be c plus 2c minus 6 equals 180. It's going to be 3c minus 6 equals 180. And I really should have wrote this a little better so that they both look the same. Okay. Now we'll add 6. So 3c equals 186. And we'll divide that. It should be 62. 186 divide 3 is 62. C equals 62. So we were able to find each of the variables with the rules that we know. Okay, here's the last one. Exit ticket. All right, we have a quadrilateral inscribed in a circle. So I would draw that, you guys, and it doesn't really matter. Don't panic that it doesn't look maybe exactly like these angles look. Just throw the letters on. A, B, C, and D. It does not matter. You've got a four-sided shape now inside of a circle, just like they said, just follow it around. Now put the stuff where it goes. Angle A is 72. It might look like 72, it might not, it doesn't really matter. B is 113. They want us to find angle C and angle D. Well, what do we know? It's inscribed, so we know opposite angles have to be 180. So I'll just take 180 away from 72, 180 minus 72, and I get 108. So 180 minus 72, 108, and that's that one. And then I'm going to go 180 minus 113, and 180 minus 113 is 67, and that's that one right there. And we found it, and you got it. Okay? Good luck with your lesson. Hopefully you guys will be all right. If you have any questions, you can get a hold of me, and we'll see you next time.